Hey, mathletes. What we're going to look at in this video is disproving conjectures. That's a fancy way to say we're going to find a counterexample. We're going to find a hole in someone's argument, and you're allowed to tell them that they're a liar. That's essentially it, okay? So a counterexample is an example that we give that shows that a conjecture is false, that someone's wrong, right? It's nice to tell someone that they're wrong sometimes, isn't it? Okay, so here we go. In each example below, a conjecture is given. Give me one example that supports the conjecture and one counter example which shows it's false. Okay, so conjecture, the sum of two prime numbers is even. Okay, the first thing I need you to know is what a prime number is. Okay, the prime number is divisible by 1 and itself, not including 1. So your prime numbers look like this, and so on and so forth. So someone made the conjecture that the sum, so we're going to add two prime numbers together and we get an even number. Okay, so 3 plus 5 is 8. Boom. We have given an example that works. Okay, the counter example to this, which we'll do in bright red, why not? Well, 2. Just get that 2 in there anywhere. 2 plus 3 is 5. All right, that's not an even number, that's an odd number. Okay, so a lot of times with counter examples, what you're looking for is sometimes maybe that one-off case. And in this case, it's because 2 is the only even prime number, and that's going to mess things up for this conjecture. Okay, let's try another one. Conjecture. In an isosceles triangles, all three angles are acute. Okay, I want you to take a second here. I want you to think about what an isosceles triangle is again, and I want you to think of how you would maybe draw me a picture that would fit this example, and then I want you to draw me, if you can, a counter example to that. So hit pause on the video, and I want you to see what you come up with. Okay, let's see what you came up with. Okay, in an isosceles triangle, so again, remember isosceles means that two of our sides are the same, they're congruent, which means the two opposite angles are congruent. So in an example that would prove this, where all three of the sides are acute, which means less than 90, I could simply make this, I don't know, let's go 80, 80, that's 140, so this angle at the top would be 40. There we go. There's an example that shows this conjecture is correct. But then it says, okay, I want one that's not acute, which means I want an angle bigger than 90. Okay, well, here I'm just going to make up something. Let's go 100. That's not acute, that's obtuse. And if that's 100, then these two down here are 40. It's still isosceles. My sides are congruent, but definitely not all angles are congruent. So there's my counter example. Okay, so I like to draw pictures if I can. I'm not a very good artist, but it helps me out. Number 3, conjecture. A number that is not positive is negative. A number that is not positive is negative. Oh, that's an interesting one. Let's make a list of numbers. Dot, 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 -3, -2, -1, 0, 1, 2, 3, right? We know this list goes on forever. These are our integers. Okay, a number that is not positive is negative. Okay, so something that would agree with this statement, well, sure, a number that's not positive. So -2 is not positive, but it's negative. All right, the counter example. Always look at 0, friends. It's such a funky number. 0, my friends, is non-positive. Is how we would call that. It's non-positive. But my friends, it's not negative either. It's neither. 0 is neither positive or negative. It's kind of neutral, right? You can see it in the list. It's in between those two things. So 0 is your counter example. Okay, let's try one more, friends. Always look for 0 in those types of questions, friends. 0 pops up a lot is how you can use as an example, a counter example. Okay, conjecture. The square of a number is greater than or equal to the number. Okay, the square of a number. Okay, I'm going to pick a number. 3. and I'm going to square it. That's 9. So what this says is that 9 is bigger than 3. 9 is larger than 3. Is greater than 3 is probably what I should have written, but is bigger than 3. Correctamundo. Okay, so there's an example that proves, or at least shows, the conjecture is somewhat true. Okay, well, that is greater than or equal to. All right, well, what if I tried 0? I told you just a second ago, 0 kind of messes things up sometimes. Well, let's try 0. Maybe 0 works. 0 squared is 0. Nah, that works. That follows this person's conjecture because it's equal to. All right, here's your counter example. Ready? What if you took the square of what? I don't know. Let's go 0.5. Okay, let's try a decimal. Let's see if that works. Okay, so we're going to square 0.5. So you pull out your trusty calculator and you go 0.5 squared, and guess what you get? You get 0.25. 0.25 greater than 0.5? Absolutely not. So this is our counter example. Okay, so it's just all about looking for these little cases, friends, finding it and showing it, writing it down. There you go. See you again.